I will give a 10-minute presentation about the development of the Drainage Master Plan for Ward 1. And if I can see the next slide, please. We basically developed this work with two main objectives in mind. Number one is to develop computer models to help us understand the drainage system of the Moss Bluff, Marsh Bayou, and the minor tributaries, so that we can identify how the system works, and we can identify problematic areas and also test a variety of solutions. We also developed or worked on this effort to put together a guideline, a master plan, so that we can provide that to the parish so that they can use it to develop or put together a maintenance plan so that they can keep up that drainage system, also accommodate and encourage developments in the future, and also provide a program for public awareness and public involvement in maintaining and keeping up that drainage system, and also give some recommendations of where to get funds to implement some of these recommendations. Next. This is the area that we're going to specifically talk about today, which is Ward 1, and the center part of Ward 1, we call it the Moss Bluff area. As you can see, that it's a pretty intricate system of drainage channels connected together in a looping system. And to the north side is the Marsh Bayou area, and all the way to the south a series of tributaries that drain to a swampy area that eventually goes to the Calcasieu River. So this is the area that we are focusing on for this particular phase. Next. This is just a few pictures from the 2006 storm. That was a very severe rainstorm that dumped a lot of rainwater in this area. And as you can see, the devastation to properties, to vehicles, to roads. So definitely we're working toward preventing that from happening again in the future when we implement some of the solutions. If we see the next slide, please. Without getting into the details of the model, we put together these models so that they can give us predictions that are representative of the actual system out there. And as you can see, the picture of the lower right corner, that is an actual picture of one of the locations just selected to show a sample. If you look at the picture on the top left corner, that is the prediction or the forecast, excuse me, if you will, from the model. And you can see that the model really did a good job of giving us the confidence that it is a tool that can be used to.
Excuse me.
That's all right. That it can be a tool that can be used to assess the different alternatives, give us good ideas or actual accurate ideas of whether a solution will work or not, how much it's going to cost, and how much benefit we will get out of these potential solutions. Next. This slide shows an overall map showing the extent of the flooding resulting from the 2006 event. And as you can see that, one event can flood an expansive area of that particular region. And those red triangles that you're seeing there, these are all the properties that reported flooding. So as you can see that there is a lot of properties that get impacted by flooding in this area. Next. After we established a confidence in the tools that we developed, we went through a thorough analysis of a variety of proposed solutions. And a range of these solutions include cleaning, and we included in the cleaning aggressive cleaning and moderate level of cleaning. And what I mean by that is depends on how often you go out there and clean. Obviously, that gives you a certain level of benefit, but also it comes at a certain cost. So we looked at that so that we can keep a balance of what is the optimum level of maintaining that drainage system. We also looked at regrading of some of the channels and also quantified how much benefit you get from those regrading. And some of them worked and some of them did not yield the benefits that were originally people had the perception of. We also looked at resizing channels, and resizing channels that includes reshaping of the channel, maybe widening a channel. So we looked at all these varieties. We also looked at constructing some detention ponds. And I fully understand that when you look at alternatives like that, it's not only engineering that plays a role. Logistics comes into play, obtaining or acquiring the land and the right-of-way. So we also looked at all these in light of the different factors that plays roles. We also looked at throughout that whole basin, where are the problematic hydraulic structures, where are the bottlenecks, if you will. And when we identified those, and we have a complete list of the structures that are currently bottlenecks, we looked at what can we do about those. Should we maybe increase the size of the culvert barrels, maybe add additional barrels, maybe replace that structure with a different type of structure, maybe a bridge, although bridges are pretty expensive. But we looked at these alternatives, quantified how much it's going to cost, and how much benefit we'll get in return for our money. We also looked at dredging new channels, and we were very careful about all of these alternatives not to solve a solution in one spot and create a problem elsewhere. So we looked at it from the regional or from the basin-wide point of view, because the last thing we want to do is shift the problem from one spot to another. Without getting into more details about the alternatives, in the document we have a complete matrix assessing how much each of the alternatives is going to cost, how much benefit is going to get in return, how long it's going to take to implement it. So we have a complete assessment, and we provided that to the parish so that they can take a look and see what we can afford and what we can do to solve some of the problems. We also provided sort of like a recipe in terms of the steps, which one should come first if we have funds, and then if we have additional funds, maybe we should go to the second alternative and so on. So we ranked them, if you will, in that sense. The next slide shows us a map that we put also in the document. The hatched area that you're looking at here, these are existing developed area. We wanted to also provide the parish with an idea where are the potential future development area, and basically it's the high ground away from flooding issues, or areas that if it gets developed, it will not compound the problem of flooding. And we also kept the areas away, the low-lying land, that if you develop there, it will cause problems. So this is also helpful to the parish to say, okay, where are the areas that we should focus our future development in? These are just recommendations, and definitely subject to detailed engineering analysis comes the time of the actual development. Next, please. One of the important components that provided in that document is listing some of the potential sources of funds for us to look for, so that we can implement some of these recommendations. The statewide flood protection program is a program that we are very familiar with. Although it does take some time, if you apply for that, it takes some time to get the actual funding. But it is a program that is actually very beneficial because the state puts up a significant amount of money. And we are qualified because we do have an existing flooding problems. That program is usually intended for existing flooding problems to address existing flooding problems. So that's one particular program that we can look for. There is a series of programs under FEMA. The Hazardous Mitigation Grant Program, the Pre-Disaster Mitigation Program, the Repetitive Loss Claim Grant, and there is one more, Severe Repetitive Loss Claim Grant. So there are several programs under FEMA, and I understand that the parish is actually pretty active in those, but this is also something that we can focus on and put grants up, especially after we develop this tool, especially after we have this document. We're in a better position to aggressively seek those funds. The Louisiana Capital Outlay is another program. Definitely the taxes is usually something that is not very favorable. You get a lot of contesting from the residents when you talk about taxing, but it is definitely one of the possibilities. Ward 1, the Roadway and Drainage Trust Fund, we understand the limitations but in that particular source, but there are programs that we can target, and we can target aggressively. Definitely, if you look at the next slide, please. The financial benefits to the parish from doing this effort. One of the important things that we can get out of all this effort is, since we have these models and we can continue to keep them up and refine them, we can actually communicate with FEMA to make sure that the flood maps are accurate. We can actually improve our community rating system. There are information that we provided of that community rating system. It ranks them from level 10 to level 1. Currently, the Calcasieu Parish is level 8, I believe, so we get 10% discount, which is very good. There's only 3 locations in the whole state of Louisiana that receive 15% discount. That is Jefferson Parish, Shreveport, and East Baton Rouge. Everybody else, these are the highest three in the whole state at 15%. We are here at 10%, and there is a number of other locations at 5%, and there are many places with zero. So definitely we are in a much better shape than other people of getting 10% discount, but we can actually go even higher if we follow that particular program. Another important thing is also to avoidance of repetitive flood damages. If we have these models that can tell us where are the problematic areas, where are the areas to avoid putting development in, that can help us to stay away from these flood claims. There is a lot of intangible benefits as well of when you get flooding, people lose properties, people lose working days, so that's obviously something that we want to avoid. Next. These are a short or a brief list of recommendations and future goals. We are reviewing and updating the drainage ordinance. We actually submit that early next week to the parish. So the more clear we are in our drainage ordinance, the better it is for future development. The inspection plan, this is something very important that came out of this whole study. The biggest component of the problem right now we have in our drainage system is cleaning. There is a lot of vegetation overgrowth. There is a lot of debris in those channels, beaver dams, and so on. So the maintaining those channels is the biggest challenge. It is expensive, and it has to be done periodically, but it's very important. Establishing the monitoring plan, I think they already started in that. This is going to be critical because so far, even though we did our very best to come up with very viable computer models, that monitoring plan will go a long way to make sure that these models are very accurate, very representative, and actually after we do gather enough data, we can refine those models and really take them to FEMA to improve our flood maps. Implementing a public awareness program. This is often overlooked, often seen as just fluff, but actually the reality of this is very important to keep that line of communication with the public resident. And I know that the parish have very nice websites and nice programs to improve that. But if you look at the pictures of the hydraulic structures, often people dispose of appliances right upstream of hydraulic structures, and without knowing that you actually be flooding your very own home by putting these appliances in there. So containing or including a aggressive public awareness program is very important to avoid these kind of situations. We need to pursue funding and grant opportunities very aggressively, actually. We need to submit those models, like I said, to FEMA for remapping. And our goal is not to increase or decrease the floodplain. Our goal is to get it right. That's the most important thing. You want to make sure that the flood maps are correct, regardless whether you are increasing the flood plain or reducing it. And the models that we already transferred to the parish is something that is going to be ongoing, and they should keep it up to always have a good handle on the drainage system. They can always test if there is a large scale or a large development coming in. They can add it in, and this way it can be a living tool, living engineering tool that is maintained here in-house to always serve the maintaining that drainage system. And with that, let's see. All I have to give a brief summary of the effort that we've done in the past year.